Welcome to today's explainer. Let's start off by imagining something together. Imagine you just jump straight up into the air. For one brief, split-second moment, you are completely free. You're literally flying. But then, inevitably, something invisible grabs hold of you and pulls you right back down to the ground. Every single time you take a step, every time you drop your keys, every time you jump in the air, you are actively experiencing the subject of today's deep dive. We are talking about the invisible tether that holds our entire reality together. We are talking about gravity.
And you know what makes gravity so utterly fascinating to me? We know exactly what it does. We use it every single day. We know how to calculate it with such incredible precision that we can slingshot spacecraft around planets and send them billions of kilometers into the deep unknown of space and land them on a dime. But despite all of that mathematical precision, here is the profound paradox. Humanity has absolutely no idea why gravity actually exists. We know the what, but we are completely in the dark on the why. Section 1. The Universe's Architect.
Okay, let's dive right into this, because to truly appreciate this mystery, we first have to recognize gravity for what it really is, the fundamental architect of our reality. It's the invisible builder that put everything you see around you together. I want you to actively visualize this for a second. Picture a reality completely and utterly devoid of this invisible pull. What actually happens if you just flip the gravity switch off? Well, it wouldn't just be some fun, zero-gravity playground. It would be total, unmitigated destruction. Without gravity, the Earth couldn't hold on to its water. The oceans would literally just float away into the vacuum of space. Our atmosphere instantly disappears. Zooming out, the dust and gas in the early cosmos would never have clumped together, which means stars would never form. And without stars, galaxies never exist. Gravity is the master sculptor. It took a chaotic, scattered cloud of ancient particles and patiently squeezed it into the magnificent, ordered universe we live in today. Section 2. Newton's invisible pull. To understand how we've tried to solve this mystery, we have to rewind the clock. The year is 1666. A young Isaac Newton is supposedly sitting beneath an apple tree and he watches an apple fall. But he asks a question that changes the course of human history. Why did it fall downward? Why didn't it fall upward or just drift sideways? He realized something had to be pulling that apple, and he proposed the law of universal gravitation. He wrote this beautiful, elegant equation that perfectly predicted how planets move around the sun. But Newton famously wrote, "I frame no hypotheses," which was basically a stunning admission of defeat. He essentially said, look, I can perfectly describe how gravity acts, but I have absolutely no idea what is doing the pulling. He couldn't explain the mechanism. He just knew it was there. Section 3. Bending space and time. So for over 250 years, the entire scientific world just accepted Newton's invisible, unexplainable pulling force. That is, until a patent clerk named Albert Einstein came along and completely transformed our understanding of the universe with one incredibly radical question. What if gravity isn't actually a pulling force at all? Einstein said we need to think of space like a giant trampoline. If you place a heavy bowling ball, representing the sun, right in the middle of that trampoline, the fabric sinks and curves. If you roll a marble, representing Earth, around the edge, it orbits the bowling ball. And this brings us to a foundational concept in this explainer: space-time. Einstein realized that space and time are connected into a single, flexible fabric. Mass literally bends this fabric under its own weight. So in Einstein's universe, the Earth isn't being magnetically pulled toward the sun at all. Earth is just traveling in a straight line, but the very geometry of the space it's traveling through has been warped and curved by the sun's massive weight. Gravity is simply geometry. Now, this sounded totally unbelievable at first, but look at how this evolved. In 1666, we had Newton's apple. Skip to 1919, scientists looked at a total solar eclipse and saw that starlight from distant galaxies was actually bending around the sun. The sun was visibly warping the space around it, proving Einstein right. And skipping to today, this isn't just abstract physics. The GPS satellites powering the maps on your smartphone right now, they have to actively correct their clocks for Einstein's curved spacetime every single day. If they didn't, your location would be off by miles. Einstein's gravity is a proven, everyday reality. Section 4. The quantum collision. So, Einstein solved it, right? We know what gravity is now. Well, not exactly. In fact, this is where our explainer shifts from a massive success story to the breaking point of modern human knowledge. This is where Einstein's beautiful, elegant math completely and spectacularly falls apart. The problem begins in the darkest corners of the cosmos, black holes.
When a supermassive star collapses in on itself, its gravity becomes so immensely powerful that it caves space-time inward, creating an event horizon that not even light can escape. At the very center of a black hole lies a singularity. Our equations say that at the singularity, gravity becomes infinitely strong. But in physics, when your math hits infinity, it usually means your theory is broken. It means there's a massive, gaping hole in our understanding of reality. Gravity is completely isolated from the rest of the universe's rulebook. We have 4 fundamental forces in nature. Electromagnetism and the strong and weak nuclear forces all play perfectly by the rules of quantum mechanics. They work beautifully on a microscopic, subatomic level. But gravity? Gravity gets a giant, glaring no. Every single time the greatest minds on Earth try to combine the microscopic rules of quantum physics with the macroscopic rules of gravity, the math just fails completely. Because the other 3 forces are carried by tiny quantum particles, scientists strongly suspect gravity must have one too. They even named it the graviton. It's this theoretical particle that would finally bridge the gap. But here's the kicker. Despite decades of the most desperate, technologically advanced searching in human history, no one has ever found a graviton. Not a single one. Section 5, the ultimate mystery. Because our current laws of physics are fundamentally broken when it comes to gravity, scientists have had to push the boundaries of human imagination to solve this quantum clash. First up is the extra dimension hypothesis. Have you ever noticed how weak gravity actually is? I mean, a tiny fridge magnet can easily pick up a paperclip, entirely defeating the gravitational pull of the entire planet Earth. Why is gravity so incredibly weak compared to other forces? Well, some scientists propose the wild idea that gravity only appears weak to us because a massive portion of it is actually leaking out of our 3D reality and escaping into hidden, higher dimensional space. And that builds right into an even grander attempt at an answer: string theory. This is the awe-inspiring mathematical pursuit that suggests the fundamental ingredients of reality aren't particles at all, but rather unbelievably tiny vibrating loops of energy called strings. Under this theory, a specific vibration of a string actually produces gravity. It's a beautiful, desperate attempt to tie the whole universe together. But right alongside it, we have loop quantum gravity. This is another incredibly complex, mind-bending theory that tackles the underlying structure of reality itself. Instead of particles living inside space, this theory proposes that space itself is woven out of tiny, discrete quantum loops. So gravity isn't a thing moving through space, it's the geometry of these microscopic loops linking together. Then, there's a theory that flips the whole script on its head: emergent gravity. What if we can't find the fundamental particle for gravity because gravity isn't fundamental at all? Think about temperature. A single atom doesn't have a temperature, right? Temperature only emerges when billions of atoms start bouncing around together. Emergent gravity suggests gravity might be the exact same way, just an emergent property of the universe that naturally arises when enough quantum information interacts. And finally, we have what sounds like pure science fiction, but is actually debated by serious physicists: the holographic universe. This proposes that our 3D universe operates like a giant hologram, projected from a 2D surface at the boundary of reality. In this wild scenario, gravity simply appears as an illusion, just a byproduct of information rearranging itself on that distant 2D surface. There is no physical pull at all, just data processing in the cosmos. Which brings us to the profound, lingering question at the core of this explainer: why does gravity exist? We know how it behaves. We know it shapes everything from the arc of a raindrop to the spiraling arms of the Milky Way galaxy. But after centuries of brilliant minds, from Newton to Einstein to the quantum physicists of today, we still don't know why reality allows gravity to exist in the first place. Is it an invisible force? Is it bending space-time, vibrating strings, or just a holographic illusion? The force that controls your every step remains reality's greatest unsolved secret, and it leaves us wondering, what completely new, unimaginable reality is waiting to be discovered the day we finally figure it out?